Hello and welcome to the Daily Space for today, Tuesday, November 19th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. Now, today's episode starts with one story, and then we wander through so many different topics. This is going to be one of those days where I think we hit pretty much all aspects of astrophysics and planetary science in one brief episode. So let's start with the results of a multi-wavelength study of a distant galaxy cluster. This particular system is interesting because it's forming stars. This simple fact means that we have caught this system in that brief window of time between when the cluster has formed and when the blasts of energy from the core around a central supermassive black hole have made further star formation absolutely impossible. Black holes themselves, they don't emit light. But as material flows toward the black hole, it builds up into a disk called an accretion disk. And this material can become so dense that it ignites with nuclear reactions, giving off massive amounts of light. This disk, which can be filled with spiraling charged material, can also generate magnetic fields that power jets that stream material out of the galaxy, further reducing star formation. The pressure from the light and these jets reshapes galaxies, clearing out their inner regions and heating the system to temperatures that prevent gas and dust from gravitationally coming together to form new stars. Once all these things have happened, star formation is over. But before that, well, that's when the magic happens. That's when galaxies that are interacting, as they so often do in the centers of galaxies, have gas and dust get knocked out of stable orbits and driven toward the galactic centers, where some of it will begin to form that deadly accretion disk. But other material, it's going to undergo rapid and massive amounts of star formation. While astronomers have long understood this is how galaxy evolution in clusters should occur, we've struggled to find a system that has a central galaxy still in this rapid star formation phase. In 2012, a team of astronomers led by Michael McDonald found indications that such an elusive system exists 5.8 billion light years from Earth in the Phoenix constellation. Newly presented observations published in the Astrophysical Journal combine data from the Hubble, the Chandra, and from the Very Large Array here on Earth to put together images that trace out the distribution of hot gas, cold gas, and star-forming regions. They find this system is converting 500 solar masses of material into stars every year. This is in comparison to our own Milky Way's average of just 1 solar masses per year. At this point in the galaxy's life cycle, the central supermassive black hole in this central galaxy, in this galaxy cluster, well, that central supermassive black hole is growing. And outbursts related to its accretion disk are still sporadic and just push the hot material outwards where it can cool. This means that rather than ending star formation, these outbursts are actually creating churning gas that actually facilitates star formation. Over time, as the black hole continues to grow, and as outbursts from the accretion disk become more turbulent and the shock waves begin to superheat the gas and dust down in this galaxy center, that star formation will end, making this cluster look like all other clusters we've observed so far. But for now, we see star formation. These observations are a great check on our understanding of galaxy evolution, and finding this rare system in the vastness of space is one heck of an awesome feat. Our intellectual hats are off to this team of observers. You can, see what they created right here. And let me see if I can figure out there. Nope, my hand is going to go under the picture. Dang it. So It's pretty. The fine blue details in the center, that is the hottest gas. That is the cold gas. That is the radio emission. The purple in the background is the hot gas. And it's a galaxy cluster. And you can see that thanks to the Hubble image that shows all the galaxies in this cluster. It's just kind of amazing. And sometimes that makes me speechless. So let's move on to our next story. So observing systems like the one that we just talked about, finding them has been a task for survey scopes. And throughout the history of astronomy, we've seen systems that have evolved from the glass plate Palomar Sky Survey through to the Sloan Digital Sky Survey, and now to the modern dark energy camera that all work to map out our sky and the structures and changing nature of our universe. Making these kinds of studies is getting a bit more challenging, however, thanks to the proliferation of annoyingly bright satellites. SpaceX, which I generally like, is systematically working to provide the world with low-cost internet, which is good, with its Starlink constellation of satellites, which are annoying. These satellites are creating a nightmare for astronomers. Last night, Cliff Johnson shared a dark energy camera image that was plagued with 19 bright stripes that were created as the latest suite of Starlink satellites passed through the detector's field of view over the course of 5 minutes. While these satellite trails can be worked around by taking multiple exposures, this increases how long it takes to accomplish science goals and eats up our limited time. The sky is only dark for so many hours each night, and the moon is only out of the way for even a more limited part of that night. Having to spend longer on every field so that we can effectively eliminate more satellites, this is going to slow science while also being really annoying to scientists. I'm in favor of providing the world with low-cost internet, but frustrated astronomers like me are going to whinge while we try and accept that this is our new normal. Ultimately, the solution is going to be launching more telescopes into space above the satellites of our frustration. We're not there yet, though. And for developing massive or experimental systems, launching things into space may never be an optimal solution. When spacecraft work well, they do awesome and amazing things, and we hope that these Starlink satellites are going to do awesome and amazing things. But for now, they're just flying through the sky, creating really stripy forms of annoyance. Yeah. Go team? Go Starlink? No, I am not Team Starlink. But I am Team Titan. This is Titan. The Cassini space probe was a top-notch example of what is possible when spacecraft are built well and allowed to do amazing things. Launched in 1997, Cassini arrived at Saturn in 2004 and would spend just over 13 years exploring the Saturnian system. And it would send back gigabyte after gigabyte of data. All this information will continue to take more years to process. And we are still seeing new informational papers published on a regular basis. This week, a new global map of Saturn, that's what this is, not of Saturn, a new global map of Titan was published in the journal Nature. This small cold moon has a thick atmosphere and a weather system that is driven by methane and ethane, which can be solid, liquid, or vapor at Titan's temperature and atmospheric pressure. In studying Titan's surface, planetary scientists have now mapped out a world with a weather-shaped terrain of lakes and dunes and even river deltas. Like every solid body in the solar system, Titan does have its share of craters, which are in red in this image, but they're relatively few in number, indicating that Titan's surface is generally like Earth's being quite young and is likely being renewed as weather erodes away the history of past impacts. This paper indicates that Titan is likely the most geologically complex system in our solar system when compared to Earth, um, with the exception of Earth. Earth is more complex. Now, this is just awesome. And one little tiny detail I want to point out is there is a Kraken feature on Titan. And so there are now Kraken named features on multiple worlds in our solar system. So when you say send in the Kraken, you are sending in, well, things from multiple places in the solar system. Now, while Cassini was able to return gigabytes upon gigabytes of data over years, more modern missions are returning their data at a much faster rate. And the deluge of data can be overwhelming. This week, the Parker Solar Probe dumped all data from its first 2 orbits around the sun into online archives where it can be explored by anyone with the power to make sense of how to use the less than straightforward data download portals. Now, I'm not going to lie. I tried to find some data I could share with you, and my 30 minutes of attempt only gained me a headache and a need to eat a chocolate Pop-Tart. This was not useful. Now, luckily, other folks have had better luck, and I was able to steal images from across the internet. This is one that you may recognize from Universe Today. It is an image of the solar corona. We have also found folks that have dove through that data archive and turned up images of our Milky Way and also of a comet as it was plunging through our solar system. So go Parker Solar Probe, and can someone please write better documentation to get the images? Please? Okay. So our final story of the day is one that I stumbled across in New Scientist, where I saw a rather disturbing headline indicating that zero-G environments can cause blood flow in some veins to reverse directions. And if that sounds like a bad thing, I am here to tell you that that is indeed a bad thing. A new paper published in the Journal of the American Medical Association, it highlights work led by Karina Marshall that shows that in a study of 11 astronauts, 6 demonstrated either stagnant or reversed blood flow in their internal jugular vein. And 1 astronaut developed a blood clot in this vein. If that sounds like a lot, I want to add that this research was inspired in part by 2 astronauts who previously experienced blood clots in space. While these clots didn't lead to strokes or other heart or lung complications, it's still troubling. And according to this new paper, weightlessness is associated with blood flow stasis in the internal jugular vein, which may in turn lead to thrombosis, that's a fancy word for blood clots, in otherwise healthy astronauts, a newly discovered risk of spaceflight with potentially serious implications. It turns out our vascular system is specifically designed to expect gravity to provide a helping hand. And like so many other parts of the body, our circulation just doesn't quite work right in space. This is just one more problem that we need to solve if we want to make prolonged stays in space safe. For now, well, researchers will watch the astronauts and publish what they find. And that's all I've got for today. I will now take your questions, and while you type those in, I'm going to remind you to please use the purple circle with a purple star in its center to highlight your questions and make it easier for me to find them in the chat. While you type them in, I'm also going to let you know this show is produced by Susie Murph and is a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are here thanks to you. It is your generous contributions that allow this show to be made day after day. This is a team that has to put all of this together, and I'm able to support that team thanks to your contributions, your bits, your subs, your patronage over on patreon.com/CosmoQuestX makes everything we do possible. The best way you can help us out is generally over on Patreon. But this month, we're trying to raise the funds to reserve all of our servers for next year. Our servers are hosted up on Amazon Web Services, and we get an amazing discount if we can prepay for everything at the beginning of the year. I'm not showing the amount of money we are trying to raise. I failed. This is the funding that we are trying to raise, and your help would be greatly appreciated. Your donations through streamlabs.com/CosmoQuestX are tax deductible where allowable by law. Now, if you can't help us out physically, we totally get it. Spread the word. That can go a long way. So you never know whose life you're going to change by introducing them to science. Okay. End of wall of text. I'm now going to see what all we have in the chat. Oh, I scrolled too high. I found yesterday. Hi, Wayne. Hi, Broken Symmetry. Hello, Paranor. Hello, Guido B. Hello, Nightbot. Hello, Larry. Hello, Kerbal. Hello, Planetary Pan. Thank you for the bits, Wayne Johnson. Oh, the dog heard. Come here. Come here. Good boy. Do you want bits and bits and bits? Here you go. There you go. Good boy. Such a good boy. Looking for questions. Pardon while I scroll. This is the least interesting part of the show. Hello, Magnethimer. I have no clue how to actually say your name. I think just Magnus. Can I just call you Magnus? Pronunciations are always welcome. Hello, Yavaltivin. Hello, Susie. Hello, Bad Banda Bear. Hello, DPI 209. Scrolling. So Larry asks, oh, thank you. Come on up. Do you want this? You do? Okay, you're a good boy. You're a good boy. So Larry asks, is this Voyager found 50,000 degree plasma? I think you're talking about, so when both of the Voyager missions left our solar system, they found in the interstellar space outside of our solar system, not extremely hot, but they found hotter than expected plasma. I don't remember its exact temperature, but that is an unrelated measurement to the galaxy cluster stuff that we were talking about today. Hello, Fenring. You used an emoticon. I cannot figure out what it is. Jasmine Wee has a very confusing emote. So Broken Symmetry asks, can a black hole ever have so much material coming in that it can't, at that moment, consume it all, causing some material to get pushed away, kind of like an overflowing blocked drain? Yes, this is actually why the accretion disks form the way they do. As material tries to fall into a black hole, the thing that slows down the process is actually conservation of angular momentum. The material just can't spiral in the way it wants to, and this leads to a disk forming, or rather, it can't just fly straight in because it has to drop its angular momentum. And as things build up in the accretion disk, what can end up happening is that accretion disk ignites and blasts material out rather than having that material fall into the supermassive black hole. So it's slightly different than the drain scenario, but conservation of angular momentum does effectively choke off material trying to fall in, causing it to instead build up and clog the drain, if you will. I need to use the right mouse. Scrolling for more questions. Hello, Limp Rimble. Hello, Raj Luthra. Hello, Hanny's Vorverp. Hanny asks, why don't we have this problem with all the other satellites? Satellites cause various kinds of problems depending on their orbit. If a satellite is in a particularly low Earth orbit and is particularly shiny, it's going to reflect a lot of light back at us around dusk and dawn and in the hour or so after and before. It's in these twilight hours when the satellites are high enough up that they're still getting sunlight, even though we're dark here on Earth, that things really go sideways. And the Starlinks happen to be really nice and shiny. We've had worse problems in the past with the Iridium satellites that became the brightest objects in the sky when they caught the sunlight just right, appearing even during daylight. Over time, most of them have fallen out of the sky, and the ones that went up to replace them weren't as shiny, were aligned slightly different. It all depends on how you construct your spacecraft, whether it's going to be a deadly reflection or just an annoyance passing through your image. The Starlinks, because they're so numerous, because they're in such a low orbit, which isn't where we stick most of the stuff, they're just a particular nuisance child. Yeah, it all has to do with the wares and how they're set up. Let's look and see what else we have. Hello, Ironheart. Thank you, human. Thank you for the bits. Come on up. I know. You're going to move my desk, aren't you? Because that's what you do. There goes the desk. How much is a gigabyte? I meant to say gigabyte. I'm sorry if I lied. No one has promised to launch 42,000 satellites before. This is true, Larry. This is true. Looking for more questions. Yes, DPI 2009. Chocolate Pop-Tarts are a thing. And they are a thing that really bad internet experiences cause me to go and drown my sorrows with when it is early enough in the day that chocolate is how one drowns one's sorrows. Those websites, really impossible to figure out, even after 2 cups of coffee. Looking to see for more questions. So Hanny's Vorverp, I agree. There's no database too difficult, but there are website interfaces to those databases between you and the database that can be a challenge. And it was the web interface that defeated me. Yeah, Planetary Pan, I agree. We do need to figure out how to create artificial gravity in space. Spinning things up really is a good solution, but it's going to require significantly larger structures. Looking for more questions. So Veronica asks, how did they find the blood clots if there was no stroke? I should know this, and I don't. I know that thrombosis can be detected due to significant pain that it causes as the clots pass through various veins. Deep vein thrombosis that people get from airplane flights occurs in the lower legs. From sitting for prolonged periods of time in the same position. It could be that they were detected due to pain or something else. I don't know the answer. I just know the generic, this is how blood clots are often detected. Looking for more questions. Hello, Michael. Thank you, Trucker Kev, the bits. Earlier, I didn't see your name. And I was looking in a different window to see who all's names I need to thank. Thank you, Kafit, for the bits, the Corgo bits. Thank you, Trucker Kev, and thank you, Wayne Johnson. Yeah, so what we need to learn related to what Fenrigo was saying about different gravity is, sorry, the dog is moving the camera, is just how much gravity do we need? Is the moon enough? Is Mars enough? We just don't know. These are things we need to figure out. So Michael asks, maybe now that SpaceX know how to mass produce satellites, they could mass produce space telescopes. I would be a fan of that. I really would be a fan of that. Partner up with Kodak to mass produce the mirrors. We're good. Elon has, I've heard, I haven't confirmed this though, talked about how he will be able to so easily launch with his super heavy, Falcon Heavy rather, massive telescopes in the future. Raj asks, when do you think we will see artificial gravity created by rotating structures producing centrifugal force? I just don't know. I don't know who it's a priority for right now, and that's really the issue. NASA is throwing all of their resources at just getting to the moon. SpaceX is trying to get to Mars. And I'm seeing a lot of the focus, with the exception of Bigelow, going into the rocketry. Bigelow has been working on designing inflatables, but I haven't looked recently to see if they're designing things that you can spin up. They are the place that I would go to look to see if it's being developed. Oh, DPI 209. I would love to visit Barcelona. You can also, however, get drinking chocolate in Cambridge, Massachusetts. Over in Harvard Square, off Harvard Square, there is a chocolater that has little tiny chocolate penguins and mice and all sorts of really artistic, beautiful things. And they also have drinking chocolate. And it was one of my favorite places to go before seeing something at the American Repertory Theater. That's memories of home. Fenrig asks, you did say gigabyte. I just went on to tangent. Oh, that's fine. Thank you. I don't know what a giga would be, but I don't know. I don't know. I've been watching RuPaul's drag show, and there's a drag queen named Jiggly, and is that a drag queen's worth of data? I don't know. Raj asks, do you think we should terraform Mars now? I think that we should build domes and do our best inside those domes, but not the entire world. First of all, there's a good chance there's already existing life there. Let's not go F that up. Beyond that, because there's no magnetic field, anything that we created would just get blown away by the sun over time. We could do a good job inside of a dome. Let's do that instead. Michaels asks, or says, I think the astronauts used some sort of ultrasonic scanner to monitor the blood flow. That's what they did in this research of 11 astronauts. They're actually doing ultrasound on the veins in the neck. But the 2 prior astronauts that had blood clots, I'm not sure how those were detected. Looking to see for more questions. Yes, this was veins, not arteries, that the research was done on. So blood on the way back. Magnus, I'm glad to know. I actually, so RuPaul's drag show is, or drag race rather, is like comfort food to me. It's I'm having a really bad day and I need someone to tell me to love myself, because if you can't love yourself, how the heck you're gonna love anybody else? Just all these different things. It's comfort food. Yes, I love that. Love that show. Okay. Anyways, Raj asks, do you think a deep space relay should be set up? depends on where. Yes, we need more relays in space. It would be great if we could better get data from the far side of the sun back over to Earth when Mars is behind the sun, when our solar probes are behind the sun. So having some relay spacecraft at various points in Earth Mars orbits would be fabulous. Uh, the Chinese satellite there is a Chinese satellite around the moon that's currently acting as a relay to get information from the backside of the moon back down to Earth. We use some of the Mars orbiters as relays for the rovers on Mars. Ultimately, we're probably going to want to have relay satellites that are sending us information from the surfaces of moons as we go out and explore them. What we don't know is what are the best places right now to stick them. So over time, I think necessity will lead us to putting relay space satellites where we need them. It's a slow and gradual process taking over a solar system. Give us time. We'll get there. Hanny asks, could you use Jupiter's L4 5 points for a relay? Yes, but is that the right place to put them? Because that means that you're constantly dealing with the brightness and the radio loudness of Jupiter. That would be annoying. There's probably better places. And what you probably want to do is like what we did when we wanted to make sure that we could have constant communications with our satellites, is put up a network that can communicate amongst themselves and get information down wherever you need it. I want to say it's the TDRSS or something. I can't remember. There was a series of 5, maybe, satellites put in orbit in the space shuttle era, and I believe they've been keeping them up to date over time, that allow us to communicate with the ISS, with astronauts, wherever they may be on orbit from Houston. And this ability to relay information around the Earth via satellite has proven super, super useful. And I can imagine that we would want to build a similar network of things all in disparate orbits around our solar system that can relay information between one another and back down to Earth. Yes, Veronica Cure, an actual deep space network that is in deep space. Yes, the Tracking Data Relay SATs. I just don't remember all the letters that were in their abbreviation. Yeah, Michael, I agree that we could see a Starlink-like constellation going in, particularly around Mars. There, DPI 209 got the acronym I was destroying. That is the set of satellites I was thinking of. So we seem to be out of questions. Today is Tuesday. Tomorrow, Annie Wilson will be here bringing you, with the help of our own R Instro, bringing you a Wednesday rocket update. I will be back on Thursday with more news. And there's some pretty cool news that is currently under embargo, so I can't tell you anything other than you want to be here on Thursday. This has been The Daily Space. My name is Dr. Pamela Gay, and I have hopefully put some science into your brain. We are a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring this solar system and beyond. We are produced by Susie Murph, and we're a collaboration with you. You make everything we do possible. Thank you for everything you do financially, supporting us, chatting on Discord, being here to ask questions. This all makes our community better, and I'm glad you're all out there. I am now going to find somebody to raid. If you have any suggestions, I am totally open to suggestions. Beyond that, I'm using the wrong mouse, trying to figure out how to transition things over. Beyond that, well, Have a fabulous morning, evening, or afternoon. And I'll see you on the other side.